Here it said that um, the question said, from our first video down to this other one now, uh, we promise to give you more calculations in the electrolysis based on the Faraday's law. In this case now, we have our question on the board. It said that 0.221 grams of a divalent metal is deposited when a current of 0.45 amp is passed through a solution of its salts for 25 minutes. Calculate the relative atomic mass of this metal. The relative atomic mass of the metal. That's what we are to calculate. And we know that 1 Faraday is always equal to 96500 coulomb. Now 1 Faraday stands for 1 electron of electron equivalent of it, electrochemical equivalent of it. That is, for divalent element in a metal here, for this divalent metal, it means that it has 2 valence electrons. That means, in that case, it will be requiring 2 Faraday. To need 2 Faraday. So let's say that the metal we're looking for, the divalent metal, is what? X. Let's say X is equal to the metal. So it means that the S plus 2 electrons will deposit the metal X. So what it means here is that 2F will deposit what? X. And then we don't know this mass, the relative atomic mass of the S we're looking for. So in that case, if it's like that, but based on the information given to us, we are meant to understand that the certain mass is liberated. There are certain mass is liberated. So what it means that we're going to find the quantity of electricity that we require to get this mass discharged or deposited. So the quantity of electricity that we require for that purpose, which is Q, will give us, and then we have our current is what? Times 25 minutes times 60. That means we want to convert it to seconds. So converting into seconds, what it means is that 0.45 times 25 times 60 will deposit 0.221 grams. So the next one we're looking at is the number of Faraday we need times this one is what will this quantity of electricity give to us. That will give us 0.221 over 4 times 5 times 25 times 60 multiply by what? Over 1. So when we multiply through and divide the necessary ones, we have 63.2. That's 63.2. That's the relative atomic mass of the substance that we're looking for. Alright, thank you so much. Now note that because this one has required 2 electrons, because it is a divalent, that is why we use 2 Faraday. And because we don't have the quantity of electricity, we don't have this mass, that is relative atomic mass we're looking for, we can always get our information via multiplying the quantity of electricity we need this to get this. Taking the ratio of it, we're able to get this thing. Thank you so much for being here.